up to here that is covered, right? Up to here all portion covered. Now next unit is started, that is application of network theorem, inductor and capacitor, source free, initial condition and transient analysis of RL circuit, RC circuit and RLC circuit. Okay, so first of all we'll have two words. One of the word is transient and another word is steady state. Okay, now first of all you should know what is transient. Like suppose I'm giving you one example, like you are entering in the room and you are entering the room at 8 p.m. and you switch on the fan. Okay, you switch on the fan. So you where the condition, the time at which you switch on the fan, that was the transient condition. Means if you'll change the thing, that was the condition for the transient condition. Okay, and before 8 p.m., tell me, the switch was off or on? Switch was off. So from a very long time, the switch was off, right? Means from a very long time, there is no change in the position of the switch. So that would be the steady state condition. Okay? Steady state condition means from a very long time, the position of the switch will remain same. Transient means that position of the switch will change. Got it? And after 8 p.m., the switch will be off or on? Switch will be on. Again, now tell me, for after 8 p.m., again for a very long time, switch will remain on only. So this is the condition for the transient or for the steady state. No, it's not like कि on steady state का है, off steady state का है, नहीं. What time से same condition है switch की, then it would be steady state, and if there is a change in the condition of the switch, then it would be transient. ठीक है? Like suppose you entered your room, you switch on the fan. So that was the condition when you switch on the fan. That was the condition of transient. Got it? Hmm? Okay. So now see, you will have transient is further divided into two category. Okay. One is first order and another one is second order. Okay. So first order means it will have one energy storing element. Got it? And second order means it will have two energy storing element. Do you know what is exactly the function for the resistor, inductor and capacitor? Tell me. The inductor is a device which opposes the change in flow of current. तो ये change को oppose करता है. But inductor की will have one more property, that inductor stores energy in the form of magnetic field. Okay, so it stores magnetic energy. And capacitor is a device which stores electrical energy. Okay, so now they said one energy storing element, तो क्या होगा, या तो L or C. So one energy storing element, either it would be RL or RC. And two energy storing element, it would be second order is RLC. So see, in your syllabus you will have both the things, RL, RC and RLC. The calculation part for first order is different and the calculation part for second order is different. Okay, so let's discuss about in detail about the first order RL. First order RL circuit. Okay, now see, you need to learn about the switch position also. Like suppose they'll give you the switch like this. This kind of switch must be told by your teacher also. Yes or no? Okay, so at this point they have written at t equal to 0. So what does it mean? What does this arrow indicates? That at t equal to 0, the switch is closed or open? No, see the arrow. At t equal to 0, the switch will be closed. Okay? And if switch is closed, then in that case, current will flow or not? If the switch is closed, no, the switch is closed, then there will be a connection between these 2 points. Then in that case, current will flow. Like इनकी language and our language is different. हम बोलते हैं कि off हो गया तो current नहीं flow करेगा. नहीं, इनकी language switch is closed means there will be a connection. Okay? And in that connection, that means current will flow. Okay? Now tell me at t equal to 0 minus, 0 minus is just 1 second before 0. Okay? So now tell me at t equal to 0 minus, just before the condition you switch the close, you close the switch. That in this t equal to 0 minus, switch is opened or closed? At t equal to 0, the switch is closed. So I am asking at t equal to 0 minus, the switch is opened or closed? It is opened. See how? For this particular condition, सबसे पहले you need to tell me for t equal to 0, the switch is opened or closed? Open. That means at t equal to 0 minus, the switch is opened or closed? Closed. t equal to 0 पे तुमने switch को open करा तो उससे पहले क्या होगा? Closed होगा. t equal to 0 plus पे the switch is opened. So you can write down this one more thing कि 0 and 0 plus वाली condition would be same and 0 minus वाली would be different. Okay? Clear? Now one thing more, that if you are having an inductor, as I told you, what is the exact function of the inductor? That inductor opposes the change in current, right? कि वो current को change नहीं होने देता. Correct? Like suppose we'll have 100 ampere of current. If from a very long time 100 ampere of current will flow, तो वो 100 ampere को allow कर देता है, right? So if it allows for 100 ampere, then will it behave like a plain wire? कि अगर इंडक्टर लगाया है, बहुत टाइम से करंट फ्लो कर रहा है, तो भी वो 100 एम्पियर ही अलाउ कर रहा है. सो currently that means inductor is behaving like a plain wire. Yes or no? Because if a plain wire is there, 100 ampere and 100 ampere, so that means inductor will behave as a short circuit. In which condition? In a condition of steady state. Okay, as I told you, steady state condition means that from a very long time the same current is flowing. So in the particular steady state condition, inductor will behave as a short circuit. Got it? This thing you need to use in the numerical, that inductor will behave as a short circuit during steady state condition, right? Next thing, one more thing you need to remember about the inductor. Like I just said to you, there is 100 ampere of current flowing. Like suppose if I change this 100 ampere of current to 20 ampere, right? So it will not change gradually in the output, it will change slowly and slowly. Like first there is 100 ampere, then after few minutes it will allow 80 ampere, then 60 ampere, then 40 ampere, then 20 ampere. Okay, because it is its property that inductor won't allow the change, right? So slowly it will not allow the it slowly it will allow the change in the current. Clear? So can we say that current across at 0 minus condition would be equal to the current across at 0 plus condition? Like suppose कि यहाँ पे t equal to 0 पे तुम्हारे पास switch क्या हुआ है, closed हुआ है, means before that उससे पहले क्या था, open था तो current is not flowing, right? तो will it change in 1 second or 0.00001 second? इंडक्टर इतनी जल्दी करंट को अलाउ करता है चेंज होना इन 1 सेकेंड ओनली? नहीं. सो दैट मीन्स यू नीड टू रिमेंबर दिस फॉर्मूला एज वेल फॉर द केस ऑफ इंडक्टर, that IL of 0 minus would be equal to IL of 0 plus, कि current across inductor at 0 minus would always be equal to current across inductor at 0 plus. Okay, clear? Now next thing about the capacitor, like inductor won't allow the change in current, capacitor won't allow the change in voltage. Okay, it opposes change in voltage. So we'll have formula कि VC of 0 minus would be equal to VC of 0 plus, कि कैपेसिटर में पहले जितनी वोल्टेज थी उतनी ही वोल्टेज बाद में रहेगी विदाउट एनी चेंज, 0 माइनस पे भी एंड 0 प्लस पे भी. ठीक है? And we'll have one more thing कि capacitor will behave as a open circuit. Capacitor will behave as an open circuit in steady state condition. How? Like capacitor, suppose I am giving you one example, like if your capacity is to eat 5 chapati or 5 roti, okay, so what you will do, like if you like your mom is saying that eat more ज़्यादा खाओ, तो you'll say कि mom enough, I can't eat more than 5 chapatis, right? Because I am full, my energy is full, correct? तो सिमिलरली कि कैपेसिटर में अगर हम बहुत टाइम से करंट दिए जा रहे हैं तो कैपेसिटर एनर्जी इज फुल, इट स्टोर्स एनर्जी एंड इट्स एनर्जी इज फुल. आफ्टर दैट पर्टिकुलर टाइम इट विल बिहेव एज अ ओपन सर्किट बिकॉज ही इज नॉट टेकिंग मोर एनर्जी. 5 रोटी खाने के बाद तुम और रोटी नहीं खाओगी, राइट? सिमिलरली कैपेसिटर फुली चार्ज होने के बाद विल नॉट टेक फर्दर एनर्जी, सो इट विल बिहेव एज अ ओपन सर्किट बिकॉज ही इज नॉट टेकिंग फर्दर एनर्जी मोर. क्लियर? So what we conclude, which we need to remember in numerical, that inductor will behave as a short circuit, plain wire, okay, and capacitor will behave as a open circuit if there is one condition for the steady state. And one more thing, कि current across inductor would be same at 0 minus and 0 plus, and voltage across capacitor would be same at 0 minus and 0 plus. Write down these things. Now see, in this case you need to calculate the current across inductor, right? So for that I am telling you the formula. Write down the formula. If they ask you the voltage across capacitor, VC of t equation, for that we'll have formula VC of infinity plus VC of 0 minus, or write down plus, minus VC of infinity bracket close e raised to power minus t by tau. If they are asking to calculate current across inductor, for that formula is IL of infinity plus IL of 0 plus minus IL of infinity e raised to power minus t over tau. Okay, so this is volts, this is ampere. Write down this formula. Based on this formula we'll do this question step by step. Okay, so I'm telling you by this formula कि in every question you have to follow the same steps, you don't need to change the thing, ठीक है? So that you won't get confused कि अभी ये करा था, अभी ये करा था. I'll make you write down the steps and you have to follow blindly those steps only. Got it? Here tau is the time constant. Tau is time constant. If there is RL circuit, then the formula of tau is L divided by R equivalent. And if there is RC circuit, then tau formula is R equivalent multiplied by C. So in both the cases, you need to learn the formula of tau. Now see how can we do this question. We need to calculate IL of T. Okay, so I'm making you steps. Step number 1, that draw the circuit at T equal to 0 minus. Okay, then if there was the case of RL, you need to calculate IL of 0 minus. If there was a case of RC, then in that case you need to calculate VC of 0 minus. So now tell me कि ये कौन सा केस है, RL और RC? This one is the case for RL circuit or RC circuit? Hello? कि if there is a inductor, I told you कि inductor का केस है तो it will behave as a plain wire short circuit, and capacitor का केस है तो it will behave as a open circuit, right? So in this case it is inductor, तो inductor will behave as a plain wire because t equal to 0 minus की condition है, that means ये steady state condition, right? T equal to 0 minus condition is always steady state condition, right? So now tell me, is there any current flowing across through this branch? Yes or no? No. So can we write down कि IL of 0 minus is 0? And मैंने तुम्हें एक और चीज बताई थी that IL of 0 minus would always be equal to IL of 0 plus. That means that is also equal to 0. Correct? Okay. Now we got one thing. We need to calculate this one now. So now we got IL of 0 plus. Correct? Step number 1 done. Now step number 2. Draw circuit at t equal to infinity. ठीक है? T equal to infinity means t equal to 0 plus, like for a very long time you are at the same position. So now tell me कि t equal to infinity पे switch is closed or switch is opened? At t equal to infinity, switch is closed or switch is opened? It will be closed. So again, step number 2, redraw the circuit, right? Again, inductor will be behave as a, now you can write down here also, at t equal to infinity, this is the condition for steady state, right? Because कि बहुत time से तुम उस room में बैठी हो. This is also the condition of steady state, correct? So inductor will behave as a plain wire. So now can you calculate IL of infinity? This is for the step t equal to infinity. So the current across inductor would be t equal to infinity, IL of infinity, right? Voltage is 10, resistance is 2. Voltage is 10, resistance is 2. So IL of infinity is how much? V by R. V is how much? 10. Resistance is how much? 2. Current is how much? 5. ठीक है. So what we got? IL of infinity is equal to 5. Correct? Now back to this. We got IL of infinity also. Right? 3 parts आ गए. Now what we need to calculate? That is your step number 3. Here you need to calculate IL of infinity for inductor and VC of infinity for capacitor. Now step number 3, we need to calculate again, draw circuit at t equal to 0 plus. Okay, so for this we need to calculate R equivalent always. How can we get R equivalent? R equivalent is always equal to the way you calculated RTH. Remember the Thevenin resistance? So remember, for the calculation of Thevenin resistance, voltage source must be short circuit or open circuit? थेवेनिन रेजिस्टेंस कैलकुलेट करने के लिए वोल्टेज सोर्स को क्या करते थे, शॉर्ट करते थे या ओपन करते थे? और करंट सोर्स को बताओ क्या करते थे, शॉर्ट सर्किट या ओपन सर्किट? स्टेप नंबर 3, व्हाट वी नीड टू कैलकुलेट आर इक्विवेलेंट. आर इक्विवेलेंट इज for that voltage source must be short circuit. This is the voltage source that must be short circuit. Resistance will be as it is, and if there is inductor, so inductor is also short open circuit. Inductor हो या capacitor हो, we need to open circuit it, and उन्हीं दोनों terminals के across से we need to calculate R equivalent. Got it? So R equivalent is how much in this case? 2 ohm, right? 2 ohm, correct? So now we need to calculate step number 4, that is tau. Tau is how much? L divided by R equivalent. L is value how much they have given? 1. R equivalent we have calculated 2, right? So tau we got it as 1 over 2, correct? Now we can substitute in the equation which we have calculated. IL of t would be equal to IL of infinity. How much we got it as IL of infinity? 5 ampere, right? So IL of infinity is 5 plus IL of 0 plus is 0 minus IL of infinity is again 5 e raised to power minus t over tau is how much? Bolo? 1 by 2. So t in by 1 by 2. So if I solve it, 5 minus 5 e raised to power minus 2t, right? 1 by 2 है तो ऊपर जाके 2 हो जाएगा. Then it would be 5 1 minus e raised to power minus 2t. So this is the IL of t, your final equation. At t equal to 0 minus the voltage, no current is flowing, the voltage across capacitor is 0, right? Next step, at t equal to infinity, capacitor would be open circuit. Now we need to calculate VC of infinity. So VC of infinity would be always equal to VAB, ठीक है? Because हमें capacitor के across से निकालना है. तो remember VAB, how can we calculate? The same way we have done VThevenin. जैसे हम थेवेनिन थ्योरम में VTH निकालते थे, सेम मेथड वी नीड टू डू कैलकुलेट VC ऑफ इन्फिनिटी, ठीक है? लाइक दिस इज A, दिस इज C, दिस इज D. सो VAB इज हाउ मच? तुम A पे खड़े हो, यू नीड टू मूव टुवर्ड्स B. A से कहाँ जाओगे? C पे. C से कहाँ जाओगे? D पे. और D से कहाँ पे जाओगे? B पे. Yes or no? Now do it further by your own. तो VAB कितना आ गया? 20. That is VC of infinity. How much we got it? 20 volt, right? Now next step we need to calculate tau. Tau is R equivalent multiplied by C, right? Calculate it. C is 1 microfarad. 1 into 10 raised to power minus 6. Resistance is 5 ohm. So 5. Tau, how much we got it? 5 into 10 raised to power minus 6. Correct? Now put it in the equation. Vc of t is equal to Vc of infinity plus Vc of 0 minus Vc of infinity e raised to power minus t by tau, right? Vc of infinity, how much we got it? 20. This one is 0. E raised to power minus t over 5 into 10 raised to power minus 6, right? So it would be 20. We can take common 1 minus e raised to power minus t by, उसको ऊपर ले जाओ. 1 by 5 into 10 raised to power minus 6 is how much? 1 by 5 is how much? Okay, so this is your homework question. This is already come in your Manipal paper, this question. So if you have any doubt, you can contact me on this number. I can take your doubt session. And if you want to study complete transient analysis or complete syllabus for Manipal third semester IC branch, then you can contact me on this number also. Thank you. Bye bye.